Suryagrahan. Suryagrahan.
Good morning, all. I would like to welcome you all to Clinomind's webinar on medical and scientific writing. First of all, best wishes to everyone on the Happy Father's Day. Today happened to be a lot of days, actually. Happy Father's Day, International Yoga Day. Today is also happens to be solar eclipse. So too many things happening on 21st June, a lot of coincidences, a lot of very critical day today. Welcome you all to this very interesting webinar on scientific and medical writing. Cliniminds, as you all are aware, is at the forefront of offering several professional skill and training programs in the medical and health sciences domain. Medical writing is a very important sort of aspect for all of us in the life sciences profession. Whether you're a medical doctor or you're a clinical research professional or you're a pharmacovigilance professional, you're a health analyst, everyone in the life sciences to medical industry understands the importance of medical writing. So hence we organize this webinar for the benefit of all our participants. I would like to introduce to our eminent speaker today, Dr. Suneet Sood. Dr. Suneet Sood is an eminent surgeon from the All India Institute of Medical Sciences, and he is currently as the faculty at the School of Medicine and Health Sciences at Monash University. Apart from his accolades in the medical and surgical domain, he's an excellent medical writer. He has a ability to make things easy. The way he teaches or does the medical writing is very unique, and hence we decided to invite him, and he sort of agreed to come as a speaker. Dr. Sood is currently located in Malaysia. I would like to now hand over the session to Dr. Sood so that he could sort of speak and take us through his presentation. I will just pass on the details to Suneet. Just give me a moment, please. Suneet, I've given you the hosting rights, and you can start your session.
Yes.
Sorry. Good afternoon, everybody. Thank you for joining today's session. Please give me a moment. I just want to ensure that Cliniminds is able to record this session. Kamal, you have been Kamal, are you able to record?
Just a minute, Suneet. I will just check. Only Dr. Sood can do it because
no, I should.
You will have to do, Suneet, or you reclaim and get reclaim.
I have to make you host.
Yeah, he is doing that. We're just doing that. Yes, Dr. Sood, you can start. We have resumed the session now. Please, you're the
All
host.
right. Okay. Good afternoon. Thank you for joining us in this webinar. In this webinar, I'll focus on writing a paper, particularly on the protocol and how to write the actual paper. And I'll spend a little time on statistics. Those of you who have an idea for a study, a research question, but are hesitant to start the process will benefit from this session. Also, if you've completed a study or you got a case report and you're wondering how to start the process of writing your paper, you'll benefit. I should mention that for this session, I have selected just one aspect of medical writing. But medical and scientific writing is a huge business. So if you wish to make a career in some other aspect of medical writing, writing for pharma companies, uh, doing some regulatory writing, or even if you wish to become a medical writer for the public, today's sessions should be of some value. It's always useful to know how the medical scientists write their papers. And this knowledge comes in handy when reading and interpreting published literature. I'm hoping that you'll find the pace of the webinar appropriate. Cliniminds will upload a recording of this webinar on YouTube, on their channel on YouTube. And I'm presuming that if you miss some points or if you need to refresh your memory, you will be able to look at the recording. A word about the slides. These slides have been prepared for viewing on a computer or on a smartphone. They're not been prepared for projection. So if you find the font too small or if you find the slides difficult to read, please do make a comment on the Zoom chat. As with all webinars involving a large number of participants, we are not able to accept voice comments and questions. But we are hoping that you will put your comments and questions in the chat. If there's time at the end, I'll try to address some of the questions. So let's move on to writing the protocol. And so we are presuming that you have an idea and you want to plan the research. The steps of planning the research are, you have to have a question or a research idea. You have to do a literature search. You have to write the protocol and then submit it for ethics and funding. Here I want to stress the importance of the literature search. In fact, the literature search and the research idea, the question go hand in hand. Without the literature search, the research question has very little meaning. You could say that the literature search actually completes completes the idea. Now you'll wonder why the literature search is actually so important. Well, for one thing, when you do the literature search, you will determine if the question has already been answered. Maybe you're walking in the wards and you see a patient with lung cancer, and it turns out that this patient has been a smoker. So you say maybe smoking is associated with lung cancer. Let's do a study. It's a good idea to do a literature search to find out if this question on the association of lung cancer and smoking has already been answered. Then again, you'll determine from the literature search if there are any lacunae in the world literature. And finally, you'll be able to plan the methods. This person has done the study in this way. It's a good method. I never thought of it. This other person has done the study in not so good a way. We should avoid that particular method. So you really need to be sure that you have seen the literature and then move on with the planning of the protocol. So you have examined your literature and you say, well, my idea is good. All right. Your research idea is good. So let's write the protocol. So the next step in your plan is to write the protocol. Now the protocol has three major parts. So when you're writing the protocol, just put the protocol headings there. The protocol headings are the background, the objectives, and the methods. Please hold for a second. I think there are some annotations going on. Ah. All right. So as I was saying, that the protocol has three headings: background, objectives, and methods. When you write your protocol, just put these headings there. Let's examine these particular sections first. The background. The background itself has three subheadings, and these three subheadings are the condition, the theme, and the lacunae in the knowledge. What is the condition? Well, the condition could be lung cancer, it could be diabetes, it could be COVID-19. What does the theme mean? Within this full domain of lung cancer or diabetes or COVID-19, you have a specific theme. You might want to know whether COVID-19 is more dangerous in the elderly or in young people. You might want to know whether chloroquine has a prophylactic role in preventing coronavirus infection. And the lacunae in knowledge is the section where you put all that is not known about that particular theme in which you are interested. Once you've done the background, you should move on to the objectives. And the trick about the objectives is that you need to be very, very specific. And I'm going to give you an example. Let's say your objective is, we want to explore the association between chloroquine prophylaxis and COVID-19. This one is not specific enough. This particular objective doesn't allow the reader to determine what your measure is going to be, how you're going to present the results. In contrast, take this particular objective. We want to compare the prevalence of prophylactic chloroquine use in COVID-19 positive and negative healthcare workers. This one is specific. In this one, you know that the results are going to be in the form of a prevalence. Then we move on to the methods. The method should always clarify these four headings: the population, the intervention, the comparator, and the outcome. And the acronym for this is PICO. And I'm sure most of you have heard this acronym, PICO. Another way of referring to these four subheadings is patients, test group, control group, and measurement. So you can call it population, you can call it patients, but the population is not always a patient. So therefore, it makes sense to call it population. Be very, very clear about the population. For example, let's say we want to do a study to determine if healthcare workers are who are taking chloroquine are protected against coronavirus. Then your population is healthcare workers, but that's not good enough. When you're writing a protocol, tell more about the healthcare workers. For example, healthcare workers who are working in the ICU of these particular hospitals form the population. The intervention, for example, would be the test group. What is the test group? The people who are taking HCQ prophylaxis. The comparator would be the control group, the ones who are not taking HCQ prophylaxis. And you have to specify what outcomes you will measure and how you will measure them. For example, you might say, I would like to measure RT-PCR for determining if the person is coronavirus positive. So you have to specify what your outcome is going to be, what you're going to measure. Okay, so let's say you have got your question, you've done the literature research, and you have written the protocol. You're ready to submit for ethics review. Obviously, in your protocol, you'll write a paragraph or more about what ethical measures you will take to ensure that the rights of the participants are protected. And if you need funds, you have to mention that as well. Before you submit this particular report to the ethics committee of your institution, check two things. One, what does your ethics committee want? In general, the ethics committee will have laid down a template, a format. Please put your submissions in this format, and then you have to adhere to that format before you submit it. And at this particular time, it's a good idea to sort out authorship issues. You must decide before you start the search, the research, who is going to be first author, who will be second author, who is going to be the communicating author. All this must be sorted out before you start. Otherwise, you will have problems. I guarantee you that you will have problems later on. All right, so we've learned how to write a protocol. Well, let's write a protocol now that we've learned how to do it. So let's imagine two doctors are meeting and they've got an idea. They just pretend that they are two doctors meet in the ward, and let's see what happens. So let's call these doctors Kamal and Suneet. So one doctor is Suneet, one is Kamal. So Suneet says, "Hi Kamal, how are you?" Suneet says, Kamal says, "Hi Suneet, what's new? Are you still insisting on taking prophylactic chloroquine? I'm telling you it's useless." And Suneet tells him, "Did you know that our hospital has been designated COVID hospital by the government?" So Kamal gets scared very easily. He says, "Oh God, let's run like hell." And he said, "No, this is an opportunity. This is an idea. We can start a study on prophylactic chloroquine and we can get the results in 2 months." So Kamal, who gets scared easily, but is a lot smarter, said, "All right, let's do it. But first we'll do a literature search." And at this point, I'm going to digress a bit and pretend to do a literature search. Stay with me. How do we do the search? You need a database which contains all the titles. You need a search engine which helps you access the database properly. Now, Google has a lot of titles, but it's got a lousy interface for scientific studies. The search source should allow you to build a search. That means you have step 1, step 2, step 3, so that you can give complex search commands to get exactly what you want. And PubMed and Ovid and other search engines allow that. And you want it to be free. So I typically, 99% of the time, use PubMed for my research. And look at this page. This is a snapshot of a PubMed page. And in this PubMed page, you can see the URL. You can see the search bar where I have typed coronavirus, and you can see the results. There are 30,000 results. But I wonder, should I type coronavirus or should I type COVID-19? Because ultimately coronavirus has been with us for years and years. So I type COVID-19 and I get 24,000 results. So I say, well, this is going to be a bit of a problem. Let me do an advanced search. So I do this advanced search by clicking on this button, and PubMed has this beautiful facility for an advanced search, and this is called the PubMed Advanced Search Builder. So access the Advanced Search Builder. There it is. And in this, when you open this page, you will notice lower down in the page, we have already got two searches, the coronavirus search showing 30,000 results and the COVID-19 search showing 24,000 results. But this advanced search builder has a search bar, and it has an ability to search within fields. If you click there, you get a drop-down menu. And for example, in this particular setting, my search number 3 is going to be coronavirus or COVID-19 only if they appear in the title. All right. Let's search for coronavirus or COVID-19 if they appeared in the title of the paper. And I get 26,000 results. So my search number 3 gives me 26,000 results. And in the same way, I have done a search for prophylaxis in the title or abstracts. I've got 96,000 results. I've searched for all papers published after 1st April. I've got 400,000 results. And I've searched for hydroxychloroquine in the title or chloroquine in the title. And I've got 8,000 results. Of course, these results apply not only to coronavirus, they also apply to lupus, and they also apply to malaria. Now, here's where the fun starts. PubMed has the facility to put all of these together. That it says, I will give you results if all of these conditions are fulfilled. So let's see this. I'm putting together search number 3, 4, 5, and 6. And all right. So search number 3, 4, 5, and 6 are now going to be put together. Can I request all participants to please mute their mics? I'm trying to mute all, but it's not working. And it may distract some other participants. So, all right. So search number 3, 4, 5, and 6 have been put together. Let's see, we were getting thousands of results. Let's see what happens with this. We have now got search 3, 4, 5, and 6, and we have 34 results. Now, this is the way that a building of a search occurs in PubMed. But before I leave this particular screen, I just want to show you the filters on the side that in PubMed, you can actually select papers which are only abstracts, or only clinical trials, only a meta-analysis. All right. So we've gone through a search. And in summary, let me say that you should start with PubMed, use their advanced search facility to build searches, search within fields like title and abstract, and use filters when you need. Once you've got your papers and you're reading the papers, there will be references in those papers. And these papers, these references within the papers are cross-references, which you should also have a look at. Let's come back to what Kamal and Sunita are doing. So Sunita is a little lazy. He says there are 34 papers. There are still too many papers to read. But like I said, Kamal is smart. He says, no, for the purposes of our study, we need only to read the methods and results for this study. So just to take a brief look at how to read a paper, you know, if you're a reviewer, you have to read the entire paper. But otherwise, you can just read the part that concerns you. For example, if you want to learn about a condition, read the introduction and discussion. If you want to write a case series review, then read only the case report part. For our for a study like ours, that means we are looking at people who comparing two groups of people. One are healthcare workers who are taking chloroquine. One are healthcare workers who are not taking chloroquine. For a study like this, we only need to look at the methods and results. So depending on what you need, you can read a paper in less time rather than reading the entire paper. All right, so coming back to the two doctors for the last time. The literature search shows that observational studies have already been done. Let's do a trial. So here's the advantage of a literature search. The literature search tells you that this aspect has already been studied and proved. It says that the RT-PCR can become negative very fast, so we need a serological test like chemiluminescent immunoassay, for example. We also know from the literature that the conversion rate among ICU healthcare workers is large, so we can take a smaller sample size. What I'm getting at is that the literature search gives you an enormous amount of information. You must do that. And so you go to write the protocol. All right, we've got that. So here's the here's the scenario. We are planning to write the protocol. Well, while we are at it, let's also write it. So you take some blank sheets of paper and you look at it and you say, okay, I've got to write the protocol. All right. You start with writing the word protocol on top and putting the headings: background, objectives, methods. Okay. Let's put in some more headings: condition, theme, lacunae for the background, PICO for the methods. Now, condition, theme, lacunae would be, in this case, the condition would be, for example, COVID-19. The theme would be chloroquine in COVID-19. And the lacunae would be a review of study on the role of HCQ prophylaxis in COVID-19. All right, we've got the subheadings. We need to put in a little bit about statistics and ethics. So we put in there, we are still on the headings and subheadings. And after the review of literature, we have realized that actually we need to do 3 tests. We need to do RT-PCR, we need to do CLI, the chemiluminescent immunoassay. We need to study their fever. So put these 3 subheadings. We've got our subheadings ready. Now we can fill it in. So we start writing, and there. And I should mention that when you're writing the statistics, you must mention how you calculated sample size, and you must mention what tests of significance you were using. Every part is about a paragraph or 2 in length, except for the literature review, which can be quite long because it needs to be complete. And you might even need to put in some tables there. And finally, before you submit the protocol, put in author information and check what does your ethics review board want, put in all the requirement, and there, your protocol is done. So you have finished your protocol, you've submitted your protocol, and you have got permission. You got permission to start the study. Okay. I'm not going to talk about doing the study because that's not part of medical writing, but I do have a small suggestion. While doing your research, it is wrong, both scientifically and ethically, to deviate from your protocol. Don't do that. All right. So now what's happened? What's happened is that you have written your protocol, submitted it for ethics review, you have got ethics approval, and you have finished your study. Now you want to write it up. All right. Let's now write it up and publish the study. Let's look at what constitutes the backbone, the skeleton of the study. The skeleton of a paper is called IMRAD. It's an acronym. The term IMRAD is an acronym for Introduction, Methods, Results, and Discussion. And I'm sure that most of you are already aware of this. The introduction answers the question, why did you do the study? The methods answer the question, how did you do the study? The results answer the question, what did you find? And of course, in the discussion, you answer the question, what does it all mean? Let's start with how to make it easy to write the introductions. Introduction consists of the following headings: condition, theme, hey, this is just like the protocol. Copy your protocol and put it into the introduction. Very easy. Plus, you must write your objectives. Now, as it turns out that it is commoner to put the objectives into the introduction than into a separate heading of its own. But it's totally up to you. You want to write introduction and objectives in separate headings? Do that. You want to put objectives into the introduction at the end? Do that. Both are all right. So you've done the introduction. That was pretty easy. Before you move on to the method section, check, do your objectives address the lacunae? In your literature, you've written that it is not known whether elderly people have a worse prognosis or younger people have a worse prognosis, but the study you're doing is to see whether chloroquine is of benefit. That makes no sense. In the literature review, you should have written, does chloroquine prophylaxis work? And in your objectives, we are trying to find this out. So your introduction and the review of literature must be consistent with the objectives of your study. All right, we've written the introduction. Let's go to the methods. We have written the protocol, we've got approval, we've done the study, and we are writing it up, and we finished the introduction. Now we're writing the methods. How did we do it? The methods headings are population, intervention. They're the same as in the protocol. Wonderful. Just copy your protocol into the method section of your paper. So whatever methods you wrote in the paper, easy. Just remember that you need to make some small changes. You need to put in stats, and you want to check a few things. One, you want to check, have you clearly written the inclusion and exclusion criteria? These particular participants were excluded. These participants were included. Have you written the ethics? Now here, you don't write, we will do this to ensure ethical compliance. Out here, in the paper you write, we applied to this particular ethics review board. We received approval according to their letter dated such and such, according to the approval number or reference number dated such and such. Just a short line showing that you have taken ethics approval. And check your methods. Do you need a flow chart? Do you need a flow chart? Now, for example, if your participants are in just two groups, that group A and group B, simple, then there's no problem. But sometimes you have participants coming in, some are excluded for some reason, then some are excluded for another reason. Then the participants are divided into few groups, and something is done here, something is done there. It can get pretty confusing. If your participants go through a process before the intervention, make a flow chart. All right, so we've written the introduction, we've written the results. It's time, methods. It's time to write the results. What did you find? And here, sadly, we don't have anything in the protocol to go on because this is the part that's all new. In the results, you have three subheadings: population information, main findings, and other findings. Put these headings down. Then fill them in. Under population information, tell the reader something about the participants. So for example, tell the reader something about the participants, their age distribution, gender distribution, how many were taking chloroquine, how many were not taking chloroquine. Maybe if you think ethnicity makes a difference, write about ethnicity. So basically, you're giving demographic information about the two participating groups in this section. Let's move on to the section about the main findings. The main findings are those for which you ask the question in your objective. In your objective, you said, we want to know the prevalence of COVID positivity. Then put that in the main finding. We want to know how many chloroquine takers develop fever. Put that in your main findings. So your main findings depend on what your objectives were. And your other findings are secondary finding that turned up which you didn't really expect. For example, you may have not intended to study ethnicity, but it turns out ethnicity has a bit of a role. Put it there. So you're about to finish with the results, but just check. Do you need to put in some tables? And in almost all cases, you will need to put in some tables. So before I move on to the discussion, let me just briefly mention some rules regarding tables. Your first question, do you need a table at all? Well, if you have 3 or more data sets, use a table. Look at the table below. You are saying that there are some countries and you are mentioning who which is the capital of that country and who are the leaders. So, if you could write that the capitals of Algeria, Saudi Arabia, and United Kingdom are Algiers, Riyadh, and London, and the leaders are President, King, and Prime Minister. However, it is better with this sort of data to put in a table. Do you need title? Do you need footnotes? The answer is yes. You always need a title, and often you need footnotes to clarify. What about lines? Now I put these red marks to see where we usually draw lines to dress up a table. They're not mandatory. A lot depends on the journal to which you will submit your paper. But a convention is you put a line above and below the box heading. This country capital leader is called the box heading. So you put a line above and below, and you put one line at the bottom of the table. Scientific explanations? Yes. You must explain the table in a way that no one can misunderstand. Suppose you got a table and you're comparing a group 1 with 2 or 2 with 3 or group 1 with 3. If you just write P less than 0.05, the reader may not know whether you're comparing group 1 with group 2 or 2 with 3. You must specify which groups you are comparing. Maybe you're comparing group 1 with a combination of groups 2 and 3. You must specify which tests you're using. Are you using a chi-square test? Are you using the t-test? Are you using ANOVA? Something else. If you have put in some parentheses, write down what do the parentheses mean. If you put in some superscripts, explain the superscripts. So your footnotes should explain the table in a way that there's no chance of misunderstanding. All right, we have done hard work and we finished the table. We finished the results. Now let's move on to the discussion to explain what does it all mean. People find the discussion very difficult. It doesn't need to be. If you know the template for the discussion is also pretty easy. The discussion has the following headings: follow the results, discuss similarities and differences, conclude, and check. Let me explain what these sections mean. What do I mean when I say follow the results? In the results, you write down the headings that you wrote in the results section. So in the results section, you wrote the following headings: RT-PCR, chemiluminescent immunoassay, and fever. Write down these 3 headings. So the headings of the results should come in the headings as headings of the discussion. Except for the patient demographics, you don't need to discuss that. Now, within each section, compare your finding with those of other studies. We found that patients who take hydroxychloroquine have a lower prevalence of COVID, the RT-PCR positivity. Our findings are similar to the findings published by ICMR. However, our findings are different from those published by the WHO. The reason for the difference is this, and then put in a reason. Next, go to CLIA. Our findings are the same as published by Sood et al. However, our findings are different from those published by Sahni et al. The difference is because of such and such reason. That's all. You have to conclude. You must round off your discussion with a conclusion. Now, it's a really bad habit to say, well, we were doing the study and there are possibilities that this will happen, possibilities that that will happen, and more studies are needed. It's not worth it. You have your data in front of you. Look at your data, decide. From my data, my decision is I will take chloroquine. So write down. We conclude from our data that hydroxychloroquine has a prophylactic role in preventing coronavirus infection. Or you look at your data and say, no, it's pretty useless. I don't think I will take it. Write that down as a conclusion. From our data, we conclude, make a conclusion as definitive as possible. And I always believe not writing a conclusion is like seeing a patient and not making a diagnosis, just doing some sort of symptomatic treatment. Bad habit. And before you finish your discussion, check. Do your conclusions derive from your results? If your results are something, your conclusions must match. I know one surgeon who was trying to publish a paper and said, I do thyroid surgery, and in my thyroid surgery, I make a very low incision. So I only raise one flap. Normally in thyroid surgery, you make an incision in the mid neck and raise one flap and a lower flap. He used to make a very low flap, a low incision, and raise only one flap. Okay, that's your style. And then he published his results. I had so many cases, so many cancers, so many benign conditions. And at the end, his conclusions were, you should make a low incision and raise one flap. It is better than a higher flap. Now, that's not in your results. Your results were not comparing the location of the flap with the outcomes. You are doing it, write down that I had good results with a low incision. But don't make it a conclusion because that's not your study. If in this study, for example, in the coronavirus study that we're doing right now, you find that doctors are scared, don't conclude that doctors should not be scared. That's not part of your study. There is no data to support your conclusion that doctors should not be scared. So the point I'm trying to make is always ensure that your conclusions match your results. And at the end of it, of course, there are so many other parts of the papers. I'm not going to go through all of these, but I do want to mention one or two things. There is an ORCID ID. Every researcher must have an ORCID ID. I suspect that of all the people attending this webinar, half of you have not applied for the ID yet. Do it now. The moment this webinar is over, do it. It's free. It is conventional to write down your strength, the strengths and weaknesses of your study. Please do it. It's important. It's a science. You must write down the author contributions. Suneet did this work, Kamal did this work, that person did this work, that person did this work. Write down. And of course, you must write down the conflicts of interest as well. So we have learned how to write a full paper. We learned how to write the protocol. We've learned how to write the paper. Let's write it. Let's write a practice paper. So we got these blank sheets and we say, how do we start? Well, we can start by writing the title. That's a start. The title doesn't have to match the title of your protocol. The title should, in general, try to give a message. Sometimes your conclusion is a good title. All right. Now let's put in the headings. Background, objectives, method. That's what we did in the protocol. And we will start with these headings in the paper. Change the word background to introduction. In protocols, it is a little commoner to use the word background. In a paper, it's usual to use the word introduction, to change that word. And remember to change past tense, a future tense to past tense. In the protocol you wrote, we will do this, we will do that. In the paper, write, we did this and we did that. So we change this to introduction. And then we put in the other headings, results and discussion. Okay, are there any more headings? Under results, population information, main findings, and other findings. We said there are three subsets to the results. Population information, main findings, and other findings. Put the headings down. Under the main headings, main findings, we had three tests we did, the RT-PCR, the CLIA, and we measured their fever. Put these headings down. There, you're ready to write. So write the introduction, write the objectives, the methods per the protocol, and for the results, fill in all of these. What about discussion? Now, I said in the discussion, you just copy the results headings to the discussion. That's what you should do. Most people start with a bit of a, just a second. So most people start with a bit of a introductory message. You can start with it. You know, coronavirus is a terrible disease and it's spreading very rapidly and there is no cure and there's no prophylaxis. You can write it, but you put it all in the introduction. You don't have to write it, but up to you. But a little bit is all right. Now we copy the headings from the results. RT-PCR, CLI, fever, and other. Okay. In the RT-PCR, we found this, the ICMR found this, but WHO found something else. Why was there a difference? CLI, we found this person found the same thing, other people found something different. Why the difference? So easy. Sum up, give conclusions, and write the strengths and weaknesses of your paper. And that's it. It was a lot easier than you might have imagined. What about case reports or thesis? Well, in a thesis, you put many more details of the work. Why do you do more details of the work? It may or may not be so relevant to the question, but a thesis is more about telling the reader how you spent your time. It's not so focused on the message you want to give as much as an explanation. Look, I spent 3 years getting a degree, getting a diploma. I have to show what I did during that time. In a case report, there's no protocol. So you have an introduction. The methods and results is replaced by the case description, but you will still need to write a discussion. All right, we've finished. We've learned how to write a protocol. We've learned how to write a full paper. We need to have a little understanding of stats, and stats sound scary. It is scary. It is scary, actually. Let me just mention a few points. So I'm going to focus on, in the statistics section, I'm going to focus on 3 aspects: standard deviation versus standard error, p-value versus confidence intervals, and univariate versus multivariate analysis. Because these are the areas where, in my experience, young researchers find the most difficulty and have the most confusion. When do you use standard deviation? When to use standard error? Standard deviation is a measure of variability within a group of readings. So take, for example, you have an orchard and you pick 100 apples at random. This orchard contains 10,000 apples. You picked 100 apples at random. When you analyze the weight of these apples, you may get a reading like this: mean weight 147 grams, standard deviation 28 grams. The variability is small. It's the same orchard after all. All right. So the 28 grams is the variability, is a measure of the variability. But if you pick up 100 people at random and look at their earnings, you may get some figure like this: mean annual income 200,000. You can put whichever currency you want. Standard deviation 250,000. Standard deviation is more than the mean income. This means that the income of these people is very variable. Some people have a very low earning. Some people have a very high earning. If your population is homogeneous, your standard deviation will be low. If your population is varied, it will be high. Let's move on to standard error. Standard error applies to samples, not to populations. it tells you how close the sample mean is to the population mean. Now you need to understand that statistics is all about getting information about this much, this many people or this many items from measuring only this many. So you measure this many, from there you want to get information about this many. So if you have measured a mean of a small number of items or people or participants or patients, this mean may match the mean of the entire population. It may not. The standard error is a measure of how closely you expect the mean of your sample to match the mean of the entire population. If your population is homogeneous, your sample will be homogeneous, standard error will be low. If your population is varied, the sample will be varied, standard error will be high. So when to use this? When to use standard error? If your study is applicable only for the population from which you gathered the data, use standard deviation. If you measured a sample and you want to apply it to a larger population, use standard error. And let me give you an example. In my college, we want to build a new auditorium. And so my dean tells me, Suneet, we want to build an auditorium. You know, our students are very rich. They come from rich families. So why don't we charge 100,000 from each of them? I say they may be poor. I tell you what, our database has the records of all of these. Just go click, it'll take you 5 minutes. The family income is there, get the data. So our college has 100 students. The principal wants to charge them for a new auditorium. If the family incomes are about the same, we'll take 100,000, whichever currency you want, from each of them. Otherwise, we'll have to charge more from the richer families. I have collected the data from all 100 because it's there in a database. I find that the average family income is 6 million per year. That's 60 lakhs per year. The standard deviation is 2.3 million and the standard error is 200,000. In this case, the standard error doesn't have a meaning. Because why? I have measured the entire population. In this example, I have taken the population of interest is only the families of the students in our college. The families of other students doesn't matter. Families of students of another college is irrelevant. Families of students in other cities, irrelevant. Other countries, irrelevant. Therefore, I measured the entire sample. All I'm interested in the variability within the sample. But let's take our example. I have evaluated 100 patients with a flu-like illness. Patients who are positive for COVID have an average WBC count of 12,000. And patients who are negative for COVID have an average WBC count of 17,000. In this case, the standard error is relevant. Why? Because from these 100 patients, I'm going to apply the information to all patients in my city with the flu-like illness, all patients in my country with flu-like illness, maybe all patients in the world with flu-like illness. It all depends on where my sampling was done. If my sampling was done from my city, I can apply it to my city. If my sampling was done from my country, I'll apply it to my country. But here's the thing. I want to apply this information to a bigger sample. How close is my sample mean to the mean of the entire population? Therefore, I will use a standard error. All right. Let's talk about p-value versus confidence intervals. The p-value is the probability that two sets of readings are the same. People who take chloroquine, people who don't take chloroquine. So the data on this group and the data on this group. The p-value tells me what is the probability that the two sets of data are the same. Confidence interval tells me the probability that repeating the study will give this a mean within the same interval. And let me clarify. Comparing two data sets, P 0.9 means there's a 90% probability that these two data sets are the same. If I do a statistics on these two data sets and find P is equal to 0.5, there's a 50% probability that these two data sets are the same. If I do a statistical test and find that P is 0.05, then there's only a 5% probability that the two data sets are the same and 95% probability that the two data sets are different. Now let's talk about confidence intervals. Take the mean weight of apples that we were doing in our orchard. Let's say the mean weight is 147 grams and the 95% confidence limits are 132, 162. 132, lower 95% confidence limit, 162, upper 95% CI. This is the mean. This is the upper confidence limit, lower confidence 95%. It means that if you do the study 100 times, in 95% of cases, the mean will lie between this. That's effectively what it means. Remember, when you repeat the study 100 times, every time the apples that you sample will be different. And if the apples that are samples are different, then your means are going to be different. But the means will lie between these two limits 95% of the time. If your 99% confidence limits are 117, 177, you do the study 100 times, every time sampling different apples, your mean will lie between these two values. And finally, we are going to talk very briefly about univariate and multivariate analysis. Univariate when you expect no relevant confounders. Multivariate when you want to rule out the effects of the confounders. Simple as that. Let's say in this study on coronavirus that we're doing, you have group A of 800 healthcare workers who took hydroxychloroquine. 48 became COVID positive, 6%. Of 1,400 healthcare workers who did not take chloroquine, 168 are COVID positive. Hey, big difference, double. But 30% of group A were male. 66% of group B are male. Maybe females are more likely to be careful. We don't know. Is the gender a confounder? The mean ages in group A and B are 50.41 years. Is the age a confounder? So when you want to remove the effects of the confounders, you go to your statistician and say, look, I have got these two sets of data. Their demographics are not the same. There are confounders. Can you please do a multivariate analysis to remove the effects of the confounders? Effectively, what you're telling the statistician is that these confounders, your software can adjust for it. The statisticians call it partialing out the effects of the confounders. So you tell the statistician, please partial out the effects of the confounders by a multivariate analysis. And in my last slide, you've written your paper. What about your journal? Obviously, you've written your paper with keeping the journal in mind. But my own policies for the journals are the first three rules: open access, open access, open access. The aim of a publication is to be read. There is too much literature that open access papers are more often read than subscription journals, the ones for which you pay. It should be indexed in PubMed because we usually start a search from PubMed. It should be cheap. So you got one journal which charges you $4,000 US, and you got another journal which charges you $200 US. Put it in this. Doesn't matter. It will be read. Once you got open access, the impact factor of the journal has no relevance. And that's the end of the session. Thank you all for listening. And I think that we have gone far ahead in time. Can I check if we can take a little more? Just give me a minute. So I'll just check with the ClearyMinds if we can take a little time. Otherwise, we'll close it here. Somebody has asked how to write a review paper. I'm sorry, this is going to take much too long, so we are not going to be able to cover that. But okay, what else, Kamal?
Someone is asking, is about.
Let me see. All right. Okay, I can see that. Okay, let me go to the chat.
You can talk about a course for 2 minutes.
All right, I'm going to answer these questions. I can see the chat, and so let me just go through these particular points briefly. You people have asked. Okay, there are lots of good mornings. Thank you. And please give an overview how to write a review article. How to write a review article. I have to say, all right, I'm going to all right, I'm going to answer this question because there are not too many other comments. So I'm going to answer this question, and I will take about 3 minutes. I'll take 3 minutes to answer this. Nowadays, the reviews are getting fewer and fewer. Journals don't like them. You should do a systematic review, not a narrative review. That means you should really review all of the literature on your topic. In my earlier days, I'd like to say younger days, but I carried on this bad habit even when I was not so young, that I'd say, well, you know, this treatment is good. And I would write a review article and including those references which supported my point of view and excluding those which did not support my point of view. Nowadays, that sort of approach is frowned on. So you must do a systematic review. In any case, the writing a review nowadays has a format. I could tell you how I've written the reviews, and they mostly sound like book chapters, but the format for reviews has changed dramatically. There's almost a template, and this template is a big advantage because the reader knows what is coming. You know, like I've been reading many reviews, so the next review follows the same template. I will understand it. And so it'll take really far too long. What I suggest is read a few reviews, read a few systematic reviews to understand how a template of a review is formed. And then you can go ahead from there. Okay, I'm going to, do we need to have more than 2 writers named in order to publish a paper? Not at all. I have published many papers and I can still publish a paper with as a single author. Nowadays, most of them are multiple authors, but you can write. You can have more than 1 writer. There's no limit on that. Eligibility to become a medical writer. That is, I'm sorry, Ms. Kanchwala, that's really, I think that's a little long. It's not going to be feasible to answer this. Can you get this PowerPoint slide? What we will do is give the recording to you. If you find that the recording is not suitable, then please write to Cliniminds, and Cliniminds will provide the PowerPoint. I have no objection in giving the PowerPoint, but the PowerPoint will need to be cleaned up. It's meant for a presentation, so there are little animations that will need to be cleaned up. So it's a lot better to ask for the recording. But if you still want the PowerPoint, write to Cliniminds. In order to perform a literature review, sources other than Google Scholar public, yes, you have Ovid, which searches the Embase database. You have Scopus, you have Web of Science. The thing is, Google Scholar is okay for a loose sort of literature review, but you want focused information. Google Scholar, for this purpose, is a terrible interface. It's not really meant for a literature review, although I have to admit, Google is the default search engine for everything, but for scientific review, it just doesn't work. And the funny thing is, my last particular systematic review was just 2 weeks ago, where I was searching 3 weeks ago, where I was searching the literature, and I had a hell of a time going through Google Scholar. I would not recommend it for a scientific review. How do you identify the real confounder? That's a good question. How do you identify the real confounders in the study? So when you looked at the demographics of your population, if you find that the demographics are different, let's say you're looking at different apples, there are two, you want to study the weight of the apple depending on the orchard, but there are too much difference in green apples and red apples. You wonder if the green apple and red apple may be a confounder. You have to keep an open mind. You have to have knowledge. You have to have a scientific approach to this. Be aware. If you don't think of a confounder which is there, you will get a wrong result. Everything is not necessarily a confounder. I don't think in coronavirus, gender is a confounder. But if you find that the demographics are different, you have to exclude gender as a confounder. So look at your patient demographics. What does ORCID ID do? Well, ORCID ID, you have to have it. You see, my name is Ashok Kumar. There are 1,000 other Ashok Kumars. They're all writing papers. You're searching for a paper written by Ashok Kumar. I will never be able to find your paper. Therefore, you must have an ORCID ID. It's absolutely mandatory now. If two people are working on the same drug, both of them have the eligibility to publish their work in the same paper. Yes, they do. Different papers. Yes, they do. If they're working together in the same lab, that's different. But if they're working, one is working in a lab in Chennai and the other person is working in a lab in London, of course they can publish the same in different papers. There's no problem at all. How to decrease plagiarism in research article? Sorry, I'm so sorry. That's beyond the scope. It's not going to be easy. How can we get templates of review? Yes, most systematic reviews nowadays are open access. Just open go to PubMed, click on the filters for review articles, and you'll get loads and loads. Look at 4 or 5. You'll automatically find a template in your mind, form a template in your mind. How to keep a look at plagiarism while writing? Ridham Joshi, this is an important question. Not how to prevent plagiarism, but how to prevent yourself from committing plagiarism. So let me answer this. It's going to take a minute, but let me answer this. You must read the paper. So for example, you're looking at my paper. You don't want to inadvertently plagiarize my paper and copy it. Read my paper, understand it, put my paper upside down, write. Read, oh, then you say, no, I forgot something. Read it again, put it upside down, write. Do not ever write while you're looking at the paper. Do not ever type while you're looking at the paper. You will always plagiarize. When you type, you're not looking at the paper. You will never plagiarize because that time when you're typing without looking at the paper, information is coming from your brain. My information coming from your brain is acceptable. That's not plagiarism. My words, you're typing, those are not acceptable. All right.
Suneet, I will take one question here.
Okay.
Someone is asking, could you please describe medical writing and aggregate report writing? Okay, medical writing is a very vast subject. It covers the pharmaceutical writing, writing paper, review articles, writing for journals, writing for the pharmaceutical company, regulatory writing, and that's where the aggregate report. So aggregate report writing a very specific pharmacovigilance related, where you write specific reports, aggregation of the previous data, individual safety data. So you write an aggregation of the reports which are PABRER for the Europe, PADER for US, PSUR format, and the DSUR for the clinical trials. So aggregate report writing is a very specific aspect, writing aspect, medical writing, but focus the pharmacovigilance sector. Right.
Okay. Kamal, do we have the time to carry on?
No, actually, we have another session starting, Sunil, soon.
All right.
And thank you. I would like to thank you, Sunil, for this session and very enlightening session and very informative. Cleared a lot of doubts for most participants. And thank you, participants, for coming on Sunday and participating in this webinar. We also offer a very sort of a focused training program in medical and scientific writing. This is a specialized course starting in August, where we cover what we have covered today is a really tip of the iceberg, and actually it's a very comprehensive subject. And in 1 hour, it's a very difficult to perhaps give everything. So we have an advanced program where you can come and take up the sort of a whole diploma course. And shortly we'll be sending you the information about this program through emails. In the next few days, you will receive the information through our business teams. And uh, very soon we'll be coming up with some more webinars, interesting topics. Until that time, thank you everyone. God bless everyone. Take care.